Hey everyone. So we should now have a pretty good understanding about the basics of POP network. Let's talk a little bit more about some POP sourcing, cases and problems. So you might have tried to emit points from something else than a sphere or a box or something. And one example could be the toy. And you might notice that when you try to emit from that, and we quickly do this with the preset POP network, which I'm not 100% sure if I explained this already, but the POPNet is a DOP network with a few basic nodes in it already. So this saves a bit of time. And let's add a gravity to this. And when we run this, we can see this weird big black blob. And when we press start, we actually see some simulation. So it seems to work under the hood, but why do we get those weird artifacts? Basically, what's happening is that the test geometry already has a shader on it. So when you press W, this disappears. So it's kind of a shading problem. And it's kind of stupid, but whenever the particles recognize that there is a shop material path, they try to visualize that in form of sprites. Now, how do I solve this? The easiest way is to simply delete the attribute that causes this, which is the shop material path. And since it's the only attribute on the primitives, we can just delete everything on the primitives, boom, and the problem is gone. There is another way that some people do, and that is in the display options, you can actually turn this off. Under geometry, you can say don't display sprites, but I would not recommend doing this because later on we will see sometimes you want to display sprites, so just turning it off is not really a good solution. Just delete the attribute and you should be fine. Now another thing is, if I actually emit from a normal sphere or some kind of normal geometry, what I will notice when I click retime, it might not seem like it at first, and sometimes it doesn't even matter, but when you look closely you can see, and maybe that's even easier to see if we don't have gravity, the points are only emitted on the surface of my sphere here. So this is actually what it has in the POP source. It says scatter onto surface. But what if I have some kind of, water tap or whatever, where I want the points to come from this area and not from this surface? Well, we actually already know how to do this, because what we've learned is that we can turn any object into a volume, for example, with an ISO offset or a VDB from polygons. And if I scatter into this, then the points will be scattered into the volume. And this way we can fill an object with points. Now, technically in the POP source, there is only just a scatter node involved. So all we have to do is we just bring in the volume version of my object into the first input, and then it will automatically, when we check it, scatter in this volume as well, just like the scatter node. So it's nothing new, it's just that we can use the same thing we already learned. So let's turn on the gravity, and very often this actually feels different, because you have a volume that you scatter from. And by the way, it also often solves the strobing problem, because since now the points are coming from a much bigger area, the strobing or stepping problem is often solved that way, or made more invisible as well. Now, also, we've looked so far at a constant emitting amount of points. So when we look at this example, for example, we have the sphere again, and we're emitting from a volume, and we have some collision object and the ground plane, of course, brought in with a merge set to mutual, and my static object with the horrible OP input path and the ground plane, nothing too special. And I changed the physical properties a little bit so that the points don't jump around. So this is how it looks like, and it's constantly adding more points to my system. Okay, but what if I have a certain amount of points in a finite amount of points? How would I handle this instead of constantly emitting new points? Now, there are two ways. One way is to use the POP source and just say, we already saw that the constant activation and impulse activation are there to animate my emission. And what I can do is I could say, for example, only emit when the current frame, and I use FF here to be absolutely safe, only when the current frame equals the start frame of my scene, which is 1001 in this case because of pre-rolls, and we will talk about this later. And only when this is the case, this will give back the number 1, which simply means in any other frame than 1001 or the first frame of your scene, this will be set to 0, which means when we press start, only on the first frame points will be emitted. This totally works, and a lot of people do this, and that's fine. But there's another way I think is worth mentioning. Because if we want to, create points just once in one frame, we don't necessarily need a pop source. For this, we have in the pop object here this parameter called initial geometry. And the idea is that we can create the case we want, which gives us also more control. For example, with a scatter. Oops, there you go. So we can really define here what we have a display bug. So let's reset the viewport. There we go. We can really define how many points we want here, or you could, use the point from volumes approach. So many ways of creating points here. And that's the nice thing about this concept. We can, outside of our simulation, create our points and then just bring them in. And we take this now as our initial state or initial geometry. And we can do this now in the pop object, and what we have to use here is either an absolute path or, again, the horrible OP input path, which we set to the first input. And now if we press start, we can see that only this amount of point is simulated. So one of the two, it's up to you, but it's very nice to know that you can create the points outside actually as a starting state, and then just simulate that as your initial geometry. And then let's come back to the strobing or stepping problem again. So what I mean by that is when you just have a sphere, and the smaller the sphere, the more you will see this effect, and the gravity, then you can see that we have a problem with a constantly repeating pattern in the emission, which you will see in the simulation. We found two solutions for this. The first one is to simply kind of make this more invisible by emitting more often with more substeps. There you go. And now it's still there actually, which you can see down here, but you don't see it anymore, and this is a viable solution. But of course, by increasing the substeps, you increase the amount of calculations. A better trick is to just use start velocity, or adding to the velocity at least, a little bit of kind of variation. And in this case particularly, Y would work pretty well. And by doing this, you can kind of create more variation in the sourcing. We've also seen a similar approach right in the beginning by sourcing from a volume instead of a surface. But there are certain cases where you will still not be able to solve this problem easily. And that is when you have, for example, moving emitters. So this sphere here is flying around the scene like Superman, and we can see that the emission problem is still there. Now, of course, again, we can increase the substeps, and this will work, but depending on how fast our sphere is, here you can see it, it will still be visible, and you might have to increase it to a pretty high number. Now, in this case, we can't use the velocity easily because this sphere is constantly changing direction. So what direction would be the right one is tricky to tell here, and an overall spread might not be what you want. For this case, there's actually already a built-in solution. It's just a little bit hard to explain, and this is why I kept it to this video, and this is the jitter birth time. So basically what you can imagine is even with substep number of 1, the idea behind this jitter birth time, because it actually describes what it's doing, is it emits points not where it should be at the current frame, but it kind of imagines where the point would be if it would be emitted in the subframes before, so in between two frames. So it still emits on the full frame, but where the points will be emitted is, an assumption where it would be when the source would be moving. So it kind of is a cheated result without having to calculate more substeps. It will make more sense once we see the results. Technically, it's actually already activated. The only thing is it's missing the interpolate source. So what you can change is from none to one of the two options forward, and this means it interpolates into, you know, the future, so to say, but usually you want back. So then you can see that it kind of creates a trail of points without, again, having to calculate more time steps. Sometimes, depending on your case, also negative can make sense and then one of the two, but just make sure that you activate the interpolate source. Play around with those things. This can be a good solution for this problem. And if we rewind and I press start, you can see, while not absolutely perfect, it's much better now because at least the point positions are better. And this is what I meant. Here you can see what it kind of does. It assumes where the point would be if the position of the source would be interpolated in a linear fashion. But this is not always absolutely correct, as you can see here. And this is why it's kind of, you know, a fake solution, but of course it's better than nothing. And it depends on your case, whether you can use it, want to use it, yada, yada, yada. And of course you can combine this technique with all the other techniques. So for example, we could use this technique and still use 2 substeps, maybe instead of 5 or something, and then we can kind of make the inherent problem disappear, and now we have this pretty good result with only 2 substeps. So as you can see, this is why I didn't want to put it into the absolute basics, but it's something worth knowing that this can solve the staggering problem as well. So yeah, those are a couple of interesting little tidbits worth mentioning when it comes to sourcing. I hope this is helpful. Thanks very much and see you later. Cheers.